Okay. Just go again. Okay. I use the fundamental theorem of algebra to determine the number zero, zero equal to the degree. We should have zero. To find one, we set equal to zero and we stack x, x, the whole thing equals zero. So what are factors of 3 plus subtract to equal 2? It's going to be 3 and 1. 3 minus 1 is 2. This tells me that my largest number is positive. So when I set each of these equal to 0, I get x equals negative 3, and I get x equals 1. So those are my two zeros, negative 3 and 1. All right, this all comes from our zero product rule, which states that any two or more things multiplied together, if they're equal to 0, at least one of them must be 0. All right, for this next one to factor, notice we have a fourth and a 2. The fourth means there should be 4 zeros. The 2, that it's only 4 and 2 means I can set it as a quadratic. So what I'm going to do is that x squared is equal to w. So I can rewrite this now as w squared plus 2w minus 3. Now that's a quadratic I'm used to. So I have w and w. Factors of 3 to subtract to 2 sound familiar. 3 and 1. Minus and a minus. Yep. Nope. Plus, sorry. And this equals 0. So now I can rewrite this substituting x squared for w into x squared plus 3 and x squared minus 1. Okay, now I can set these equal to 0. Hopefully I might be able to see this as factorable because this is a different system. I'm sorry, which one am I talking about? You can't even see which one I'm talking about. I actually now have a laser pointer. This one right here, the x squared minus 1, is factorable because it is a difference of squares, so I would get x plus 1, x minus 1. But I'm going to show you that you don't have to be able to see that to successfully solve this equation. All right, if I set x squared equals, or I should say plus 3 equals 0, I get x squared equals negative 3. So x is going to equal plus or minus the square root of negative 3, which, as we know, is an imaginary number. So what I get is x equals plus or minus root 3i. Okay, so there's two factors. Then I take x squared minus 1 equals 0, x squared equals 1. Square root both sides, x equals plus or minus square root of 1 is 1. So there's my other two. So I have 4 altogether, plus and minus 1, plus root 3i and minus root 3i. All right, here, notice my 3 is actually 5. I'm going to shift this around and put the 5 beginning. Okay, so I'm not sure exactly. I mean, we'd take a lot. We'd have to graph this and stuff. But I think on this one, everyone knows how many zeros. I just was showing you how many and how to find them. This one would have 5 zeros. You may again have some imaginary, but there would be 5. Finding zeros. Find rational zeros of polynomial functions. Determine the first step. Determine possible rational zeros. Remember, factors. Oops, I forgot my R on that factors. Of the trailing constant over factors of the leading coefficient. These are our possible zeros. They won't all work, but some of them will. So now we graph the equation and look at what we think are approximately these numbers. So where it's actually crossing is going to be somewhere in this, these numbers, okay? So that narrows our list. Then we use synthetic division by dividing out those zeros to test to see if we can make them divide out evenly. All right, find conjugate pairs of complex numbers. Determine possible rational zeros. Graph to narrow the list. Use synthetic division to verify the rational zeros. Factor the remaining quadratic to determine any imaginary zero. All right, this is just the list, okay? Finding zeros of polynomials is what we've just said twice over. If given a factor this time, divide it out. If it's a linear factor, if you're told that, for example, x minus 3 is one of your factors, x equals 3 is one of your solutions, divide it out. If it's a quadratic factor, you have to use long division. If I have x squared minus 2 as a factor, I have to divide that out first. Long division because of the x squared. Determine possible rational zeros by graphing. We determine the possibles, leaving tailing coefficient over leading coefficient. Graph to narrow the list, use your synthetic division, and then factor your remaining quadratic. All right, here's your class practice. Go ahead and go work on that and double check your answers with what I show here. Any questions, come on in.